Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll show you the improvements that were made in multi-axis simultaneous machining, in particular Swarf machining. Let's start by taking a look at the part that we have on our screen. If we take a look at these walls over here, you can see that these walls have a negative draft angle over here, as well as on this side over here, and also they have a draft angle on this wall over here. Although they all have negative draft angles, which need to be done using 5-axis simultaneous. Now, what Swarf machining actually does, it actually allows you to work on these surfaces without having to pick all the extra parameters such as the direction, the tilt direction of the tool itself. Everything is done automatically within the options of Swarf machining. If I were to open up the operation, you can see we're using the option of Swarf machining. Now, Swarf machining, if we go into geometry, has several different ways of actually choosing what we want to do. The different types of strategies. The default strategy is actually automatic, where all you have to do is actually choose your Swarf faces, and this will automatically give you the direction. Now, if I were to open this up, you can see there are other options here as well, such as synchronize with tilt lines, synchronize using the upper and lower curves, synchronize with main directions, and shortest distance. But we'll start with the automatic. And the idea behind this is that it leaves you trouble-free without worrying whether or not the tool will gouge into the part, whether you have the right angle. It'll do this automatically. In this particular case, I'll have my surfaces defined as follows. These walls around the part over here. And I also am going to do floss surfaces. If I were to show you my floor surfaces, I've chosen the actual floor itself, which is not a straight floor, but actually a curved floor. Plus, I've also chose the fillets around the part itself. And that's all I really have to do. If I go into my tools, I chose my tool as 6mm ball and mill. And as far as the rest of the options goes, I did not do anything with tool axis control. Nothing else was done over here. The only thing I did add in over here was in my link, my first entry, I used a lead-in that I have over here of tangential arc. That's the only thing I added in, was my lead-in. If I were to take a look at the simulation itself, you'll see that the tool will go down and actually work automatically without me telling it what the tilt angle has to be. This is done automatically within the Swarf machining operation. As you can see, it's going around the part, machining that entire area exactly the way it needs to be machined. And you can see it's also tilted exactly the way it should be tilted, going around the wall itself without me giving it the actual tilt angle that it needs, but it's done automatically within the operation itself, completing the walls exactly the way it needed to be finished. Now let's go back into the part. Let's add a few more passes to our tool pass. For example, we've machined this wall, but I did this all in one step. If I want to do it in several steps, all I have to do is go into roughing and more, and I can just add how many steps I want to have it done in. For example, if I write down 10 steps and do save and calculate and simulate the part, you'll see that our tool path is actually going down in 10 steps around the part. As you can see, going down all the way to the bottom. Now, I can also take into account if I have a lot more thickness on the wall itself to do this in actually several layers. For example, I can say I want to have it done in 3 layers, having a distance of 2mm between each layer. If I were to run my simulation after the calculation, you'll see that the tool actually goes down in its first layer 10 times, then its second layer, and then when we finish at goes down the third layer as well. Taking a look from the top view of the layers itself, you can see that we have 3 different layers. Each one of these is 2 millimeters apart and going down a total of 10 times on the wall itself. For more videos on SolidCAM Professor, please go to our website www.solidcam.com and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.